Good morning. Sometimes we can reduce the solution to a problem with a particular set of input values to the solution of the same problem with a smaller set of input values. For instance, the problem of finding the greatest common divisor of two positive integers a and b, where b is greater than a, can be reduced to finding the greatest common divisor of a pair of smaller integers, namely b mod a and a, because the greatest common divisor of the remainder of b divided by a and a is equal to the greatest common divisor of a and b. When such a reduction can be done, the solution to the original problem can be found with a sequence of reductions until the problem has been reduced to some initial case for which the solution is known. For instance, for finding the greatest common divisor, the reduction continues until the smaller of the two numbers is 0, because the greatest common divisor of a and 0 is a when a is greater than 0. Definition 1. An algorithm is called recursive if it solves a problem by reducing it to an instance of the same problem with smaller input. Example 1. Give a recursive algorithm for computing n factorial, where n is a non-negative integer. So the C++ code is unsigned int factorial, unsigned int return n greater than 0 question mark n times factorial of n minus 1 colon 1. So what that says is we're going to take only non-negative integers, and we're going to ask the question, is n greater than 0? And if it is greater than 0, then we're going to return n times factorial of n minus 1, calling factorial recursively. Otherwise, in the case where n is equal to 0, we're going to return 1. Example 2. Give a recursive algorithm for computing a to the power n, where n is a non-negative integer. So what we're doing is a is a real number, so we have to return type double, which is a real number, or at least in computing it is. And we're going to call our function power, and we're going to take double b, where b is the thing that we're raising to a power, and unsigned n the power. So when n is greater than 0, what we're going to return is b times the power of n minus 1, calling power recursively. Otherwise, we're going to return 1. Example 4. Give a recursive algorithm for computing the greatest common divisor of two non-negative integers a and b with a less than b. So I have an unsigned int, GCD unsigned int a and unsigned int b. Return a is equal to 0. If a is equal to 0, return b. Otherwise, return the remainder of b divided by a and a. And so I have a main routine here that prompts for this and gives you a result. Example 7. Prove that algorithm 2, which computes powers of real numbers, is correct. Solution. We use mathematical induction on the exponent of n. If n is equal to 0, the first step of the algorithm tells us that power of b comma 0 is equal to 1. This is correct because b to the 0 power is equal to 1 for every non-zero real number b. This completes the basis step. Inductive step. The inductive hypothesis is the statement that the power of b comma k is equal to b to the power k for all b not equal to 0 for the non-negative integer k. That is, the inductive hypothesis, the statement is that the algorithm correctly computes b to the k power. To complete the inductive step, we show that if the inductive step hypothesis is true, the algorithm correctly computes b to the k plus 1. Because k plus 1 is a positive integer, when the algorithm computes b to the k plus 1 power, The algorithm sets power of b comma k plus 1 to b times power of b comma k, which is equal to b times b to the k power, which is equal to b to the k plus 1 power. This completes the inductive step, and it completes our lecture.